Somewhere out past Jupiter right now, there's a comet racing through our solar system that formed before our sun even existed. Not just older than Earth, older than the sun itself, older than the entire system of planets we call home, drifting through space for roughly 10 billion years before it ever wandered close enough for a telescope on Earth to notice it. And when NASA finally pointed the James Webb Space Telescope directly at it, what came back genuinely surprised the scientists who had been waiting months for the chance to look. This is the story of Comet 3IATLAS, only the third confirmed interstellar object ever detected passing through our solar system. The strange chemical fingerprint Webb managed to pull out of it before this ancient visitor disappears back into deep space forever. Stick around, because the numbers behind this discovery are honestly hard to wrap your head around. And if you want to catch every update the moment new data comes in, go ahead and hit follow before we get into it. Let's start with how this object was even found in the first place, because the story behind the discovery matters just as much as what came after it. On July 1st, 2025, a network of automated telescopes called ATLAS, short for Asteroid Terrestrial Impact Last Alert System, spotted a faint, fast-moving object out beyond the orbit of Jupiter. ATLAS exists specifically to scan the sky night after night, looking for anything that could pose a threat to Earth, catching asteroids and comets that other survey programs might miss. Almost immediately, astronomers realized this particular object was moving strangely. Instead of following the kind of curved, closed orbit that every native comet and asteroid in our solar system follows, this object was on a hyperbolic trajectory, a path so fast and so straight that it could only mean one thing. It wasn't born here. It was just passing through on a one-way trip that started somewhere else in the galaxy entirely and would eventually carry it right back out, never to return. This made 3IATLAS only the third interstellar object humanity has ever confirmed, following the strange cigar-shaped object called Oumuamua in 2017 and Comet 2I Borisov in 2019. Each of these visitors has been an incredibly rare opportunity because, unlike every comet and asteroid native to our own solar system, which formed out of the same original cloud of gas and dust that created the sun, and planets roughly 4.5 billion years ago, interstellar objects carry material that formed around a completely different star, under completely different conditions, sometimes billions of years before our own solar system even existed. Every time one of these objects passes through, it's essentially a free sample delivered from somewhere else in the galaxy, and scientists know they only get a limited window to study it before it speeds back out into the darkness for good. Once 3IATLAS was confirmed, astronomers scrambled to observe it with every instrument they could get access to, and the early estimates were already impressive. Researchers determined the comet's icy core measures somewhere around 7 miles across, and it's moving through space at roughly 130,000 miles per hour, a speed so extreme that it's currently the fastest comet ever recorded passing through our solar system. In August of 2025, the Hubble Space Telescope captured what was, at the time, the clearest image ever taken of an interstellar object, showing a compact, glowing coma of gas and dust surrounding the comet's icy nucleus as sunlight began warming its surface for the first time in billions of years. Around the same period, NASA's SPHEREx mission also turned its attention toward the comet, gathering additional data on its size and detecting organic molecules within that surrounding cloud of gas, adding another piece to a puzzle that was only just beginning to take shape. Then came James Webb's turn, and this is where the story gets genuinely fascinating. In its very first look at 3IATLAS, Webb discovered something researchers hadn't fully expected. Rather than a coma dominated primarily by water vapor, the way most comets in our own solar system behave as they warm up near the sun, 3IATLAS showed an unusually large amount of carbon dioxide surrounding its nucleus. That alone hinted that this object formed under different conditions than the comets we're used to studying, conditions where carbon dioxide ice was more abundant or more easily released than water ice. By December of 2025, as the comet made its closest approach to the sun and then began moving back outward into deep space, astronomers realized they had a limited but incredibly valuable window to study it in even greater detail. As 3IATLAS warmed from its close solar pass, its ancient ice began actively venting gas into space, essentially giving scientists a fresh, glowing sample of material that had likely remained frozen and untouched for billions of years. Researchers used this opportunity to turn Webb's mid-infrared instrument, known as MIRI, toward the comet, capturing what became the very first detailed mid-infrared chemical fingerprint ever taken of an interstellar object. Those observations, conducted in 2 sessions in mid-December, while the comet sat roughly 205 million miles from the sun, revealed the presence of methane mixed into the comet's outgassing material, another piece of direct chemical evidence about the conditions under which this object originally formed. But the most striking results came from a separate instrument entirely, Webb's near-infrared spectrograph, known as NIR-SPEC, which astronomers use to map out extremely specific chemical ratios hidden inside the comet's coma. What they found was described by the research team as genuinely surprising. NIR-SPEC detected exceptionally high levels of deuterium, sometimes called heavy hydrogen, roughly 30 times higher than the levels typically found in comets native to our own solar system. Deuterium is essentially a heavier version of ordinary hydrogen, and the ratio of deuterium to regular hydrogen inside a comet's ice acts almost like a chemical thermometer, telling scientists something about the temperature and radiation environment the material was exposed to when it first formed. An unusually high deuterium ratio. Like this suggests that 3IATLAS came together in an extremely cold environment, one that was bathed in significant radiation over a very long period, but that never experienced the kind of sustained warmth that would have reprocessed that heavy water ice into the more familiar type of water ice we're used to seeing here on Earth. Alongside that discovery, Webb's instruments also picked up on something equally telling, an unusually low ratio of carbon-13 compared to ordinary carbon-12 inside the comet's material. This might sound like an obscure technical detail, but it actually carries a surprisingly elegant explanation. Over time, as generations of stars are born, live out their lives, and eventually die throughout the galaxy, the overall abundance of heavier isotopes like carbon-13 gradually increases, seeded into interstellar clouds through the process of stellar nucleosynthesis. Our own sun, having formed relatively recently at only about 4.5 billion years old, incorporated a fair amount of that accumulated carbon-13 into the material that eventually became our solar system's comets and asteroids. But 3IATLAS showed only trace amounts of it, an indication that whatever cloud of gas and dust this comet originally formed from hadn't yet been enriched by nearly as many generations of dying stars. Taken together, these two pieces of evidence, the unusually high deuterium levels and the notably low carbon-13 signature, allowed researchers to estimate just how old this comet actually is. According to the study, led by astrochemist Martin Cordner at NASA's Goddard Space Flight Center and published in the journal Nature in June of 2026, 3IATLAS likely formed somewhere between 10 and 12 billion years ago during a period astronomers sometimes call cosmic noon, an era in the early universe when star formation across the galaxy was happening at its most intense and rapid pace. If that estimate holds up, it makes 3IATLAS not just an interstellar visitor, but very possibly the oldest comet humanity has ever directly studied, a genuine relic from a chapter of galactic history that predates our entire solar system by more than twice its current age. Cordner himself put the significance of this moment in fairly striking terms, describing the observation as a rare chance to study an ancient object likely older than the Sun, giving researchers direct insight into a distant time and place while simultaneously revealing just how unusual our own solar system might be by comparison. That second part is worth sitting with for a moment because it flips the usual framing of these discoveries on its head. Most of the excitement around interstellar objects focuses on what they reveal about other star systems out there in the galaxy. But comparing 3IATLAS against comets native to our own solar system also teaches scientists something about how relatively young, how relatively carbon-enriched, and how comparatively warm our own corner of the galaxy actually is, set against a visitor that spent the overwhelming majority of cosmic history drifting through a much colder, much older environment before it ever crossed paths with our sun. There's also a broader scientific mission quietly tucked inside all of this. NASA researcher Stephanie Milam, a co-author on the study, explained that beyond the fascination of finding these rare isotopic signatures, the bigger picture involves understanding the possibilities of prebiotic chemistry elsewhere in the galaxy, the basic chemical building blocks that, under the right conditions, can eventually lead toward life. So far, Earth remains the only place in the entire universe where scientists know for certain that those chemical ingredients actually assembled into something living. Every interstellar object that passes through our solar system offers a small, precious opportunity to ask whether similar raw ingredients exist elsewhere, carried on a comet formed around a star system. Humanity will likely never visit or directly observe any other way. A separate team of researchers, using the European Southern Observatory's Very Large Telescope and led by astronomer Cyrielle Opitom, has been independently studying the ratios of carbon and nitrogen inside 3IATLAS through the chemical signature of cyanide gas, adding yet another layer of confirmation to the picture. Webb has been building. Multiple instruments, multiple research teams, and multiple independent lines of chemical evidence are all now pointing toward the same conclusion, that this object really is chemically distinct from anything native to our own solar system and really does appear to be extraordinarily old. What makes all of this even more remarkable is the sheer narrowness of the window scientists had to work with. Interstellar objects like 3IATLAS don't loop back around for a second pass. They arrive from interstellar space on a single straight trajectory. swing past the sun once, and then continue outward, eventually leaving the solar system permanently and disappearing back into the vast darkness between the stars. Everything researchers now know about this comet's age, its chemistry, and its likely origin had to be gathered during the brief months it remained close enough and bright enough for telescopes on and around Earth to study it in detail. Once it fades from view, that opportunity closes, likely for good, at least until the next interstellar visitor happens to wander close enough for astronomers to catch it in time. That urgency is exactly why NASA pulled together such a wide coalition of instruments to study this single object, interrupting Webb's regularly planned observation schedule, coordinating with Hubble, SPHEREx, and ground-based observatories around the world, all working together in a race against the comet's own trajectory. It's a reminder of just how rare and fleeting these encounters really are. Only 3 interstellar objects have ever been confirmed passing through our solar system in the entire history of astronomy, and each one has taught scientists something new about how different and how similar other corners of our galaxy might actually be. So somewhere out past Jupiter right now, Comet 3IATLAS continues its long journey back out into interstellar space, carrying chemical fingerprints from a star system that existed long before our sun ever ignited, offering one final fleeting glimpse into conditions from nearly the dawn of galactic history before it disappears from view for good. And back here on Earth, researchers are still combing through everything Webb managed to capture during that narrow window, piecing together an increasingly detailed picture of where this ancient traveler came from, and what its unusual chemistry might be able to tell us about the possibility of similar chemical building blocks existing somewhere else entirely in the galaxy. If a story like this, an object older than our own sun passing silently through our solar system and giving scientists just enough time to catch a glimpse of it, is the kind of thing that genuinely fascinates you, go ahead and subscribe. Drop a comment letting me know what surprised you the most about this discovery, and stick around, because there's a very real chance the next interstellar visitor could show up sooner than anyone expects.